So we're looking at this function that arises from this thing that's Zenzizenzicube. This is the function. It's a composition of 3 different functions, and so we want to use the chain rule to find the derivative and then use the properties of exponents to simplify it and then find the derivative. We should get the same answer. I'm actually going to start with this part of the problem here. The function is in the form y is equal to f of n is equal to g of u is equal to h of x, and there's the triple composition. Let's just take a look at that first real quick. So I have the function written down here. There it is. Y is equal to f of n is equal to g of u is equal to h of x. So the way the function is defined, notice that h is the innermost function, right? And there it is on the innermost. That's the x to the 3rd function. And then if you sort of just ignore the f part and just look at what is g of h of x. Well, what is g of h of x? Let me change something real quick. What is g of h of x? Well, that would be the function that you get when you take the h function and you plug it into the g function. Okay, so there's the x to the 3rd. Plug it in for u there. That's going to be x to the 3rd squared. Okay, and notice that that's exactly what you see right here. That's the x to the 3rd squared. Okay, then if we continue, what is f of g of h of x? Well, that means basically that we just take the function that we just did. This is the g of h of x. That's all of this. You take that whole thing and plug it into the f function. Okay, so basically take this whole thing and plug it in for the n there. Okay, so what happens when we do that? Well, that's when we get the x to the 3rd squared. So we're taking that and plugging it into the n right there. So that will itself be squared. Okay, so that's the way that you can approach the composition part itself. Now for the chain rule derivative, what we want to do, if we want to take the derivative of this thing here, in other words, what is d dx of all of this, f of g of h of x, for that, when we use the chain rule, we work from the outermost function in. Okay, so that means we want to take the derivative of the f function first, leaving the inner function alone. So that's f prime of the inner function g of h of x. Okay, and then we work our way inward. So the next innermost function is the g function here. We take its derivative, we multiply it by what we just got here, so that's g prime, leaving its inner function alone, that's the h of x, so the g prime of h of x. And then finally we have one more inner function, the innermost function, the h of x, so we have to finally multiply it by its derivative as well. So that's the h prime of x. Okay, now if you put this together with the actual function, looking at the actual function, the outermost function is this squared function, so you're going to first take its derivative, leaving the inner ones alone, the x to the 3rd squared, so x to the 3rd squared. And then again we lower that by 1, so really there's like a first power there. And then we multiply that by the derivative of the next inner function, which is x to the 3rd squared. Well, that one itself requires the chain rule, so to do that, 2, bring the 2 in front, leave the inner function alone, x to the 3rd, and then again that 2 gets lowered to a 1, and then finally we multiply by the derivative of the innermost function, which is that x to the 3rd. Its derivative is 3x squared. Now if you combine all this stuff together using the properties of exponents, you multiply these, so you're going to get, and then if you take all the constants, 2 times 2 times 3, that gives you 12, and then this is x to the 6th, multiply those powers together, x to the 6th, and then we've got x to the 3rd and x squared again, so that's another x to the 6th. Or no, I'm sorry, in this case we're adding the exponents because we're not doing a power to a power, so here we add the exponents. 3 plus 2 gives you 5, so that's a 5th power there. And then finally, again, use the properties of exponents to add these exponents. Get 12x to the 11th power. Okay, now in part B it says to use the properties of exponents immediately and just take the derivative that way. So in other words, just look at the function immediately like this, x to the third squared, oops, x to the third squared, and then instead of using the chain rule, just use the properties of exponents. Now here we do have a power to a power to a power. We're going to be multiplying all three of them. 3 times 2 is 6 times 2 is 12, so this would be the same thing as then just saying, well, what's the derivative of x to the 12th power? Okay, well, what is the derivative of x to the 12th power? Using the power rule, you just put the 12 in front, and then you lower that exponent by 1, and you get that, which is, of course is the same thing that you would have gotten by using the chain rule. Okay, I know the chain rule is definitely a confusing thing, but this is the explanation of how you would do it multiple times with a function like this.